Okay, so welcome to the fourth Python tutorial. This is gonna be tutorial number 4 on the Python math series on how basic algorithm is work and basic Python and also basic mathematical algorithm. So today we start with exercise 10, which is finding all the divisors of an integer. So as you probably know, an integer can be divided. It can be either a prime number, which only has two divisors of one in itself, or it could be a composite numbers. Here we are not talking about 0 and 1. Those are not classified. So, for example, for number 12, we have the divisor like 1, 2, 3, and 4, and also 12 divided by 6 and 12 as well. So the divisor of 12 is 1, 2, 3, 4, 6, and 12. So for example, a prime number like 13, so only have 1 and 13, only two divisors, and uh you know maybe one just have divisor 1 and 0. For example, 0 will have infinitely many divisor, you know, etc. Infinitely many divisor because it's a 0. So it's basically all the natural number except for 0 itself. So that's the idea of divisor, and now we're gonna write a program to find all the divisor about a given integer. So for example, now we have to input the integer, right? So we will say number, right? So now we wanna input the integer. So it's gonna be an integer type data. So int, and now we want to input. So input, and now we want to have a prompt to ask the user to input the integer. So enter the integer, right? Right. Right. Okay. All right. Okay. So now we have the integer. What we want to do is that we want to find all its divisors. So okay. So for example, let's take for example number 12. So we want to find its divisor. We want to check from 1 because nothing can be divided by 0. So we want to check from 1 up. So if 12 divided by 1, okay. So 1 is the divisor, and 2 and 3 and 4 are all divisor of 12. 2 is divided by 12 is divided by 2, so 2 is a divisor of 12. 4 is a divisor of 12, but 5 is not a divisor of 12. So we're gonna just check up until we get all the divisors, okay? We're gonna check from 0. Oh, so yep, number. So now we have to we have to find the divisor of the number. So yeah, the algorithm would check if the number is divided by any other number that's smaller than it up to itself, and it's gonna add to the list of divisor that we're gonna provide. So here's algorithm. Okay, for I in range, we want to check from 0, and we want to check from 1 because nothing can be divided by 0, so 2 and plus 1. Because we want to have n as well, so we have to check to n plus 1 because n is obviously a divisor of n by itself, so that's self-evident. So n plus 1 if n divided by that number, divided by I equal to 0, and then we're gonna do something after that. And now, because the best way we can show in this situation that we want to print out the list of divisor from which the list of divisor, right? We want to print a list, so now we have to create a list object, create a list, and we're gonna left it as a blank list, and then the algorithm gonna add the divisor onto the list, so we're gonna have a list with elements inside. So this is how it's gonna go. So list 1 equal to, we're gonna leave it now as a blank list. So if okay, so now for I in range 1 to n plus 1, if number divided by I, then I is a divisor of the number that we input, right? So now, because I is a divisor, we're gonna add I into the list, and then we're gonna print the list out as the list of divisors. Okay, so list 1 dot append I, and we can print the list of all divisor of the number is the integer is, and that's we're gonna print this one now. That's all. So let's hit and run. So for example, we're gonna print number 12, and then so here it has to be numbers, right? Sorry. Let's run again. So it has a few mistakes. It should not be n, it should be the number. So yeah, it's easy. This all divisor is. We run again. Let's check the 30. So okay, so how about we check something more observed, like okay, so we check to 0. We're gonna try a few ones before we check the 0. Let's pick up a composite number like 69. Yeah, so it has 4 divisors, and now we just pick up a prime. Prime 47 is a prime. Let's look for 47. 47 7. So now, how about we plug in 0? How about we plug in 0? So, because 0 has infinitely many divisors, so actually the computer cannot process it, so it returns to a null list because there actually the infinitely many number of the list. Okay, there is infinitely many elements in the list, so the computer cannot handle it, so it returns a null list. Yeah, so that's how it goes. So exercise 10. So yep, we're gonna move to exercise 11. Alright. Okay. Okay, so exercise 11 is how you're gonna express what is called complex number inside Python. So complex number is essentially just the number I. You know, that's the imaginary number, and I square is -1, and I doesn't remain. You know. I doesn't lie inside the number range. It lie on the perpendicular axis to the number plane, which is, you know, complex number is a good way to solve cubic equations, and it's a very convenient way. Actually, it's the standard way that we have to expand our real number, the dimension of the real number, to be able to solve cubic equations. So yeah. So here we're gonna see how it goes in Python. So x equal to 0 plus 1 times j, and then j, and then j. Okay. And then print x squared. So in Python, the imaginary unit is denoted by J, as some in physics textbook, but mathematically it's normally gonna be I, but here in Python it's J. So let's see how it goes. Yeah, that's exactly. It gives you a -1 plus 0j, which is the standard definition of the number I or j in this scenario. So I square or j square is -1. So yeah, that's the imaginary unit. J square is -1. So yeah, that's how it goes. Okay, so now we come to exercise 12, which is write a Python program to calculate the area of a regular polygon. Alright, so Now we're gonna have a polygon. Let's have a hexagon. So we're gonna calculate the area of this figure, this regular polygon, regular hexagon. So okay, so it has the side length of 8. Okay, so we're gonna have to calculate the area of it. So okay, that's how we do it. We don't have any formula. Don't know how to do it. Quite difficult. So maybe we quit the exercise. No, we don't quit the exercise. Let's break it down. So we know how to calculate the area of a isosceles triangle, right? The area of isosceles triangle, quite straightforward to calculate. Maybe I gonna do it again here. So, but I gonna tell you how to calculate it. But here, let's break this down. So. So basically you see that all the components in small triangle are isosceles because it is equilateral in this form, but let's take it as isosceles. So now we can calculate each of the area of the isosceles and triangle, and we're gonna multiply by the number of the triangle, which is the number of the side of the polygon, to get the total area of the polygon. So let's calculate the area of each individual triangle first. So yeah, we want to calculate this. Okay, so we know the size A, okay, and we know this angle. Okay, this angle is x, right? So we know that x is gonna equal to P and CP divided by A, which and is the number of sizes, and is the number of the sizes of the polygon, because that's obvious. We divide into n triangle. We divide it in 6 in this case, but we wanna divide it by n for a arbitrary number of triangles. So n is number of sides, right? Number of sides. So the total area wanna be the total area, which is A, will be n times the area of one triangle, so it's n times over time, which is a of a small triangle, so let's denote it by AT. So now it's our mission to find out AT, right? We have to find out AT, so yeah. Have to find out AT. So here, let's say what we know about AT. We know its side, and we know its base, and we know its we know about AT. We know its base length. Here. Here we know this baseline, which is A here, and we know the top angle, okay, which is x, and x is equal to 360 over n, okay. So we can calculate 80, right? So 80, which is basically here, this was h, right? This is h. So 80, and this is gonna be what we must calculate, right? Yeah. So 80 equal to 1/2 of AH A and H times H, right? Alright. So now we have to calculate H because we don't know H. So, but we also know that but now we have to calculate H, right? We have to know H, but here we know H. Okay, so this is a square triangle, and this is A over 2. Okay, so we can calculate it by H to A over 2 and also to X over 2, right? So it's A over 2 here, A over 2 here, and here we have is X over 2, so X over 2. So we can calculate H via A over 2 and X over 2, which is equal to H via equal to so A over 2 the other side times 10 of the times 10 times cosine of the cosine of the X over 2, right? So that's how it goes. So that basically, because the Python we don't have cosine as a function, so we can do it say A over A over over 2 times of 10 X over 2. Okay. So we now we have the formula, right? So we have formula. So now we can calculate 80, and by the way, we can calculate A. So 80 should be so 80 should be 1/2 of A squared. So 1/2 here, so it's gonna be A squared, right, over 4 times 1/2, and 1/2 is 4 times X over 2. X over 2, right? Okay, 4 times X over 2. 80. That's 80. So yeah, because we have to time A to A and 2 to 2, so that's how it goes. So now we can calculate A, which is basically, and we're gonna substitute x for 330 over n, so we have to type n in, so it's gonna be n a squared, so, and then we have to substitute in, so 4 times is there, and well 10. Okay, so x is 360 over n, so and that divided by 2 gonna be 180 over n. Okay, so that's the final formula. Alright, that's the final formula for the equation calculating the area of the polygon, an equilateral triangle. So yep, that's how it is. So let's execute it. So now we have to, what we're gonna have to input is the length, the side length, and the number of lengths, because the number of lengths we decide the number x, right? So number n, so number n here, gonna decide number x, right? And we calculating by using number x. So the two variable we're gonna have to input, which is essentially n and a, right? So do it. So from not import 10, right? We're 10, right? Oh, right, we're 10. So one put a, okay, and we will to it's integer, and it's gonna be the number of the side of the equilateral of the polygon, right? And it's the number of side polygon. So let's note it down. Okay, so let's note it down, and number of sizes of the polygon. So int input the number of size of the polygon is, right? Okay. Then we're gonna say the area is equal to n a equal to float input the length of the polygon side is, okay, so a is silent, okay, so area gonna be equal to n, so with n times a squared over. 4 times 10 là 1. 4 times 10 of 10 of 100 over 10. That's it. Okay. Seven. So which one to so now you know. So so eat the area of the polygon is so we'll print out the area. Okay, so let's just run if there is any wrong thing. Okay, so let's say 3. Let's say 1. So for equilateral triangle, let's say if here we have this one here. If we have an equilateral triangle, so this is one here, and we have here this is gonna be 1, so this 60 cos 60 sin 60 is sin 60 is square root of 3 over 3, so is 1/2 1 times 3 over 2, so square root of 3 over 2. Okay, so it's gonna be square root of 3 over 4. That's the area of this equilateral triangle. So we're gonna check if this works. So oh, it's funny. So let's calculate again, right? 1/2 of 1 times this square root of 3 over 2, which is quite correct, right? Yeah, so square 3 over 2. The area should be smaller than 1, right? I was calculating it correctly, so square root of 3 over 4 is okay, so I'm gonna check it later. So size square, obviously times size square. Square root of 3 over 4 over sine square, which is obvious, right? and this is 3 over 4. Okay, so square root of 3 over 4. So that is an but this is only an isolation. Yeah. I think this formula is correct because we derived it otherwise. So yeah. I think we derived the formula from a general case, so I think it's not wrong. Yeah, I think it's not wrong. So if I got made a mistake, please comment down below to let me know, and I'm gonna fix it. So yeah, the code works, and you can just enter the number of side of the polygon is 3, and then you can calculate anything. Oh, so I want to make another note is that okay, so if because you cannot input a number of a size smaller than 3, because a polygon has at least 3 sides. A polygon has at least 3 sides. So if you enter 2, it's gonna be a false, and if you enter 1, it's gonna be a false. So if n smaller than 1, then print wrong input, okay, wrong input, okay. And else, okay, so we enter the side here, copy this, and we're gonna paste it up here. Just gonna paste up here, yeah, to the number of sides and the side length. Else area equal to, and then we print wrong input, and let's see how it goes. No, this is if n smaller than 3, right? Okay, I'm sorry about that. Smaller than 3. Right, so let's say 4. 1. Yeah. Probably I made some mistake, but I'm gonna fix this later. So yeah. So this is the Python tutorial, and yeah, let's fix this now. What's wrong? Because number of size 4 and the side length is 1, so which means that the area should be 1, right? Because that's square. So let's see. Wait, was we wrong on this? Okay, so let's take a new one. Save. Repeat. And let's say the square, right? Let's say the square. So we can divide it by 4. So area gonna be n, which is 4, right? Times, and this in side formula. A square, which is 1 square, over, and this is 4 times 10. And this is 1. Of 180 over, and which is 4. Right. So 1045. So we have to search for 1045. 1045 is this one. So yeah, it's just on. So it works. So this formula works. So yeah. So we're gonna mistaken this for a degree. So so I know what is the problem. The problem is that the program are running in gradient mode, and what we are using is a degree mode. So how to use degree on Python, right? So we search and how we want to use degrees in gradient. So how to input angle degree in Python. Okay, so it's worked by radian and formulate everything. Yeah, so it is radian. So essentially, I just have to change this to pi, right? This is radian is gonna be n a squared 4 over 10. So 180 degree, 180 degree equal to 1 radian. So yeah, so this one is 1 over n. Oh, 180 degree gonna be equal to pi radian. Sorry about that. 180 degree gonna equal to pi radian. So this is just essentially pi over n. So I think this is gonna solve the problem. Yeah, that's the formula. So let's say this pi, and from, and say I'm gonna have to import another n from math, import pi. Okay, and that's it. Let's run. So 4, number of size 4, and number size is 1. So it's 1. It's this 002 is a calculation error. So because the computer calculated in a discrete, not continuous function. So yeah, it's likely that it has some error there. So no problem. So how about we run it again? Is 3. So okay, we run it again. Number of size 3 and silent is 1. So okay, so what we expected from the calculation is square root of 3 over 4. So square root of 3 over 4. So 0.433. So 0.433. So the code is corrected now. We have to use the radian. Radian units for this kind of computation, because that's what Python run by. And here we're gonna do the radius by just changing our formula from 180 degree to the tan of pi over n. That's all. That's simple. We just change 180 to pi, and that's gonna work. So, yep. So. Here. So this is the code for today. So yep, that's the end of our fourth Python tutorial. So we hope you are enjoying our lessons, and thank you very much for listening. Be safe, keep healthy. Thank you. All the best.